Here's something which is relatively new to the language. It's variable arity methods, and this is what it's all about. Now, it's possible with these to declare a method that takes a variable number of parameters, and the method is said to have a variable arity, and it's done like this. Put the return type in, the name of the method, any fixed number of arguments, and then a type for a variable number of arguments, and those three dots there are important. I don't know if they're going to show up too well, but they're important. And for once, the three dots now is actually part of the language, and what the compiler does is it simply translates that, and it translates it into that. So that's really fairly simple. It's all done by the compiler, really. And if you call a method like that, it might look something like this. And so return type R, a method, and T1 corresponding to that type, T2 corresponding to that type, and a variable number of T3s. As many as you want, and it gets translated by the compiler again into well, basically that. Okay, so there's nothing too difficult about it, really. Some remarks about it. These are all fairly obvious remarks. Only the last argument can have variable arity, otherwise you wouldn't know where it started. All of the variable parameters have to have the same type or be a subtype of it. So these T3A, T3B, and so on, they've all got to be of type T3 or a subtype of T3, obviously. If the final argument in some method or other is an array, that will look like that, then an overriding method can be the equivalent, have the equivalent variable arity type. So I could count that in, that would count as an override of that. You're allowed to use that form as an override, just treat them exactly as equivalent. And you can do it the other way around too. If you've got a method that looks like that, in code that overrides it, you can use that method, that as a signature. And it counts as valid. Although that way around is discouraged. It's considered bad because it's well, it's not modern. It's considered to be the latest fashion, so you're supposed to use that and not override that with that. But well, you don't gain anything anyway. Okay, let's just summarize the rules for this overriding, hiding, or implementing methods. Right then, first of all, the method names have got to match. That's a pretty obvious requirement. Next, the argument types must match. And by matching, the array form and the variable arity form are considered equal as far as matching is concerned. And actually, the argument names, of course, they can be anything. That's just a sort of documentation thing, really. If they don't match, by the way, if your argument types don't match, then you're not overriding, you're doing what's called overloading, which is something different. And we'll cover that next, in the next lecture, I think. So okay, they've got to match, and in the same order as well. Any throws clause in the overriding method must not throw an exception not covered by the overridden methods clause. Okay, and strictly speaking, of course, this only applies to checked exceptions. Now, when we cover exception handling, why this only applies to checked exceptions and what unchecked exceptions look like will all become clearer. So don't worry too much about that. I'll just say that unchecked exceptions are things that you can't really do anything about. They're things like the virtual machine running out of memory. There's absolutely nothing you can do about that, so there's no point in catching it. And if you had to catch all the unchecked exceptions, because there are so many and they can be thrown by anything, divide by zero errors and null pointer exceptions and stuff like that, you're just too much of a burden. So the language designers basically decided that they divide exceptions up so that those which are checked by the compiler are all subtypes of a particular type, or subclass I should say, because these are classes. And unchecked exceptions are subclass another class. Actually two classes, but never mind. I don't want to go into too much detail. Okay, now the next thing is if you override a method returning a primitive type or a void or void, then you must return exactly the same type. Otherwise, you may return a subtype of the overriding method. Sorry, no, a subtype in the overriding method. That's better. Any overriding method must have the same or wider access, and usually you keep the access the same, normally. Right, those are the 5 rules, and if you do that, you've managed to override or implement or hide, depending on whether you've got an instance method, static or abstract. Now, let me just say there's nothing wrong with an abstract method, and that would be in a class, of course, overriding a concrete method. And you can do that, there's nothing wrong with it. Of course, if you try and run it, though, you'll get a compiler error. But that's not a problem either, because you've got the thing's got to be an abstract method and have to be in an abstract class. It means you're forced to subclass it. So the actual override that's taking place will be overridden right the way down to the real concrete class. So you'll never end up accidentally running it. The only way you could do that is by using super from the subclass, and that will try and force the thing to run. But if you try that, the compiler will know that you're trying to run an abstract class and tell you can't. It'll give an error. So this is not it's not a safety problem there. It works. It's quite okay, and it's sometimes done as well. Now, just think of abstract as meaning that you must override the method in a subclass. That's the easiest way to think of abstract.